Welcome back to the Roll-Up High Roller community. As always, nothing on the roll-up is to be construed as financial advice. We are just educators in the DeFi space. Toss us a quick like, give us a share, a repost, send it to a friend who may want to watch this, and finally, give us a sub or a follow. It means the world to help support credibly neutral educational content in DeFi. We're here to educate, empower, and enrich you, and let's jump in.
Welcome to DeFi by Design, where we talk all things blockchain and cryptocurrency while striving to educate, empower, and enrich.
So welcome back to the DeFi by Design podcast. Here today, of course, with my boy Rob. Got my Scroll shirt on. I think it's the best shirt that I copped at DevCon. It's kind of like a custom fit, Rob. What do you think? Is it wearable on a date or no?
Debatable. I remember seeing the Scroll shirt. I thought the quality was amazing. The only thing is the collar. It's like a real big collar. So I don't know. It's like a half turtleneck kind of thing on a t-shirt. It's different. It's unique. It's good to see you again, Andy. And today we got Rushi, king of the VMs. How you doing,
guys? Not too bad. Not too bad. I would probably not wear that shirt out in public unless it's a crypto conference. Maybe put a flannel over that. It does look like a turtleneck a little bit, so that is my issue. But I love Scroll, so it's a good show.
Swag.
We have movement swag. We will have a date. It will be ones you can wear on a date. I promise.
That is the litmus test of crypto swag. I promise.
Yes. And then we need a real movement party. That's a real party.
Movement party at ETH Denver?
You didn't hear from me.
Oh, man. So, Rushi, why don't you introduce yourself a bit about kind of movement? Obviously, you have an interesting past in crypto, kind of different programming backgrounds, and why you guys are building Movement Labs.
Yeah, so Movement Labs is building the first move layer 2 on Ethereum, powered by Celestia for DA. Our kind of background comes from the Aptos ecosystem. My background personally is engineer. So started off at my career in systems, database security at United Health Group, kind of entering that space over there. Then got into the crypto bug pretty early on the engineering side, thinking around Solidity, Cosmos, Wasm, Rust in that space. And then around like August of last year is kind of when I stumbled across Move. I was like, Facebook, the biggest consumer app and social network in the world, looked at the currency on blockchains and was like, this is awful. We need a better VM. We need better parallelization. We need better formal verification built into the VM so that we can actually build technology that billions of users on Facebook could use. It was like literally, I would say 2 years ago, I want to say that decision was made. And then that was a DM project from Facebook. Fortunately, to regulation, it couldn't ever see fruition and got split up into both Aptos and Sui. Personally, I built the first DEX in Aptos. My co-founder built the first yield aggregator in Aptos. So we're some of the earliest builders in the Move space and recognized that there's a lot of issues that we couldn't directly handle on the infrastructure side. And that was around the time when the modular thesis kind of picked up and realized the real market fit for a Move VM to exist within the modular system. So that's led us to build Movement, the first Move layer 2 on Ethereum.
How did you meet Coop? Sorry, finish that thought.
Yeah.
I'm just like, where did that come in?
We met at a conference. Me and Coop actually went to the same university. He was a little bit older than me, but we're just like, you're playing Aptos and you go to the same university. It was a cool like jamming session. We kind of worked together on like some Move ideas, and like he built a yield aggregator, so naturally like we were partners kind of. But around like post FTX, that's kind of when we kind of linked up and decided to go all in on this.
Very cool. And like on the note of like partnerships, like, and also speaking about Andy's Scroll shirt, like you guys have found a way to position yourself so that you're friends with essentially like potentially everyone in the industry.
Yep.
And that's also like our thesis and our perspective on the industry. Is like if you can come up with an innovative positioning where you're able to like befriend everyone rather than compete with one another, then you are probably building something valuable in the space. So like how when you're looking at the space like as a whole, maybe we'll use Scroll as an example. Like how do you partner with someone like Scroll, and then how do you keep an open enough mind to partner with essentially like all these new tools and chains that are coming up, on a daily basis?
I think when we looked at the modular thesis, there was a clear market for DA, right? You had like 3 big dealers, and like now near getting into space, you had a bunch of RAS providers in space, and a bunch of like roll-up stacks. So you had like a Polygon SDK, you had the OP stack, you had CK stack. I don't think Scroll is a stack yet, but I'm sure they're coming out with it soon. But there's a lot of competition, but everyone was saying like, we'll do all these customizations, but leave the EVM as it is. When most people recognize that the EVM was actually the biggest bottleneck, execution after data availability is the biggest bottleneck on Ethereum. A, from a security side, there's $4 billion lost every hacker attacks, and B, on the throughput side, like pretty much every EVM chain tops at 100 TPS, which if you ever try and get a consumer app on chain, is pretty problematic. So that's kind of how we kind of have this unique edge in the market where everyone is our kind of friend, because no one's really competing on the execution layer level. And even if you are, like this Fuel, obviously, there's a Solana VM, and in that manner, it's not tribalistic at all because the overall market wants to dethrone the EVM. So even though there are other styles of virtual machines, and you can argue whether the SVM is better, or the Fuel VM is better, or the Move VM better, the real challenge is dethroning the EVM and generating mindshare for overarching virtual machines. So the current state of the market is like everyone's kind of competing to race to the bottom, but the execution layers are where there's kind of innovation on that side. And kind of like how we partner with Scroll is, and these other like layer 2 frameworks is Optimism obviously has Optimism chain, and then they have the OP stack, Arbitrum has Orbit, ZK Sync has ZK stack. So we can essentially bring the Move VM to these ecosystems. We have like a Move stack where anyone can launch a Move rollup, use whatever stack they want, use whatever DA they want, use whatever sequencer they want. We're not competing at that end. We just give them the VM. It's the first MEVM, so it's fully EVM compatible. So works, talks, and looks like EVM, but has a Move VM running under the hood. So it's like a parallelized virtual machine. You have formal verification built into the VM. So we stop like 95% of all attack vectors we're seeing slowly, which I'll get more into later, I'm sure.
For anyone who's like unfamiliar, does dethrone the EVM mean dethrone Ethereum? Or like after you take out the EVM, what else is left of Ethereum?
Yeah, so like that's not at all what it means at all. Like Ethereum is still the best place to settle transactions. By TVL, it like kind of takes up all of DeFi, if not pretty much everything. Like you have Ethereum, now Solana with the recent rise. But the Ethereum is not the EVM. In fact, most people in the Ethereum space agree that EVM is a hot pile of garbage. It's single-threaded, Solidity is pretty broken, it can't scale. But Ethereum itself is a great settlement layer. It's very decentralized, has a lot of TVL and mindshare, and it's security, or it's like secure storage of value. So the way we kind of look at it is bring this next-gen VM, bring the superior technology to where users are. In the past with monolithic chains, you always had next-gen VMs, you always had like cool technologies, but it was really difficult to get adoption because everyone is still on Ethereum, despite whether you like it or not. So modularity allows you to bring in experimentation, so you can experiment on Ethereum without leaving Ethereum.
Yeah, even further going down that kind of rabbit hole, when it comes to the VMs, man, what is a VM? What is a virtual machine?
I think like your computer has a virtual machine. It's like an operating system where, like in traditional Web 2, you can write code and it'll compile down. Like every app you're using on your laptop, Mac, is connected to the Chromium or connected to the Mac OS. So you can have like a Windows virtual machine, you can have like a Mac virtual machine. In blockchain specifically, it's how smart contracts can interface with underlying consensus mechanism. So like Ethereum consensus is not itself able to be accessed by a developer or user, but Ethereum virtual machine can be accessed. So you can think of like the validator set, which is like the network, and the virtual machines on top of it that communicates a user or developer to the underlying settlement layer. A great analogy is like Swift, for example, communicates between different banks, but the actual settlement layer is underneath that, which is like the communication between banks and the financial system that exists today. So Ethereum is just like a better financial system, but there's better ways to communicate with Ethereum than the EVM.
Yeah, awesome. Just wanted to throw that one out there before we dive into the weeds here, because so I'm super curious as to why you believe that alternative VMs have a place. And let's just scrap EVM from our thought here. let's look at a world of just what are known as alternative VMs. But what are some of the benefits of some of these tech stacks that have been around for a while? What kind of capabilities could we expect, or innovation possibilities, I suppose, could be endless, but what kind of capabilities could we expect from non-EVM or just other VMs, and why is this happening? Why do these alternate VMs offer better capabilities than some of the rest of the EVM?
Yeah, I'll break this down to two sections, performance and security. I think performance inscriptions was a great example of what chains can scale and what chains can't. We saw a lot of, if not every EVM chain pretty much go down with the rise of inscriptions. Some chains completely halted, while other chains had like extremely high gas fees. Although inscriptions is an edge case a lot of people didn't take into account, it kind of highlights like in the world where you actually have 1,000, 10,000 users on chain at the same time, can the network handle it? And when you look at what networks handled it, it was Solana handled it pretty well, Aptos, Sui handled it pretty well, and I think Near and Say handled it pretty well. The common denominator there is like alternative VMs in the space where you have parallelization built into runtime. So instead of the EVM, which is single-threaded processing, which you have to wait for a transaction to finish each time, you can have parallelization in that transaction can execute concurrently. You have parallelized databases, like what Manad's working on and Say is working on. So just able to handle users on chain is a huge benefit from a performance point of view because you have parallelization. Specifically, Move has a block STM pattern, which was designed by the DM project. A superior way to do parallelization and handle transaction threading. On the second part of performance, specifically Move is the concept of dynamic NFTs. We're seeing this in gaming where Sui gaming has really taken off. Where in the past, let's say like DeFi kingdoms, on the chains they were on the past, they kind of broke the chains, if not halted the chains, because you're constantly minting and burning new NFTs. So let's say, for example, a game actually gets 1 million users on chain. In that world where you have 1 million users on chain, you're going to have tens of millions of traits being minted and burned in because there's no way to swap out traits at will. With Move and this virtual machine that can take these opcodes, you can swap out traits at will. So say, for example, you kill 1,000 zombies and you need to upgrade the caliber on the gun or upgrade the skin on like for your individual. You can do that within the smart contract itself instead of needing to constantly mint and burn a new NFT each time you update state. That's on the performance side. So you have high throughput chains as well as customizations on smart contracts, which enable low fee and better UX purposes. On security side is kind of where Move takes the cake. It was built with formal verification in mind. For those who don't really get it, formal verification is kind of what auditors do. It's their job. They formally verify each line of code to make sure there's no bug there, there's no restricted attack, there's no integer overflow, and even then, it's not 100%. We saw that recently with the Kyber attack, the Curve attack, which are two blue chip protocols, both ran few bugs, and every week it seems like there's a new attack. The total number is like 4.5 billion to date every year lost in attacks. So if you're buying this thesis that crypto is going to be adopted at mass scale, it can't be done on a Solidity or EVM because it can't scale. Bank of America will never put their assets on the EVM because it just won't house their user funds safely. Even talking liquid funds, they can't get insurance to completely back their like kind of investment because there's a high smart contract risk. So Move introduces the concept of formal verification where every smart contract that's deployed goes through a formal check at runtime. So it checks for resource type and memory safety, blocks reentry attacks, blocks flash loans, and some of the other major scale attacks we're seeing. So next-gen VMs are the fastest and most secure way to scale Ethereum.
Gotcha. Rob, you go ahead because after this, I'd like to do a little bit of a build your own modular roll-ups and get Rushi's opinion as to how we really craft something.
Yeah, that's always a fun exercise. I did have like a quick tangent, which is that you mentioned parallelization as kind of the thing that enables high throughput chains. I'm curious how parallelization, which is a very difficult word to say, how is that like similar or different from atomic composability? And I'll just kind of like say my understanding of it, and then maybe you could like correct me where I'm wrong and then fill in any gaps. Yep. I heard Charles from Espresso speak about atomic composability, how it arrives at a more efficient prices much quicker. And this is done by essentially putting transactions into the same sequencer, and then any kind of like coincidences that happen, to use CowSwap's term, cancel out, and then those are able to eliminate any kind of settlement bloating, if you will. Parallelization seems to be very similar because you can run transactions in parallel. If those transactions have coincidence of wants, is there a way to like let those settle atomically, or is transactions in parallel not necessarily composable with one another?
Yeah, so the best way to explain this is atomically composable refers to multiple different blockchains. So let's say you have like 8 different rollups or 10 different rollups. Composability refers to like, can you do swap between rollup A, rollup B, rollup C, rollup D, rollup F between different networks? Parallelization refers to state between one specific network, which mostly refers to database. So it looks at read and write calls between a specific chain. So let's look at Solana, for example. Solana is not atomically composable with other chains because you need like wormhole, you need a third-party bridge to bridge assets between Solana and Ethereum. But Solana is parallelized and can execute on state in a parallelized runtime because you can have like 1,000 transactions all occur at the same time, and it's composable within a specific network. So atomic composable refers to a multiple network, while parallelization refers to state within a specific chain.
That makes sense. Is parallelization, like, is that the end all be all? Like, this has been the hot term, but like, is it really that powerful? And if so, like, is it just a matter of like the local fee markets? Or I know Say is different than Monad than insert other VMs, but is it just local fee markets, or is there other aspects that make parallelization better other than just like cost or basic throughput, which are ultimately kind of the same thing? You either lower cost or get more throughput. It's the same kind of thing. Is it that just it, or is there more to it?
Yeah, so parallelization itself doesn't do much. I would say it's like a 5x increase or 6x increase, which if you're doing 10 TPS, it brings you like 50 TPS. The real adjustments and modifications that's been pushed is the DB. So on the Aptos and Sui side, they use like RocksDB, which is a modified version designed for the block STM pattern. And there's also like how you integrate with consensus mechanisms. So parallelization is just one piece of the pie. It refers more to parallelized like consensus, parallelized database. Parallelization as a whole is like a system. Parallelization of the VM itself, it's just one small piece, which isn't that difficult to do. It just refers to having multiple threads within a virtual machine. The real bottleneck is on the database, which Monad specifically focuses on, and that's why they're able to do like the parallelized EVM. The way we look at it is we kind of inherit a lot of the benefits of Aptos and the DM virtual machine. So we have our own modified version of RocksDB, which can handle the high throughput and can have all the benefits that Monad DB does. So it's like equivalent. We handle EVM equivalency through EVM runtime, while Monad and Say kind of build it directly into the VM. So it's kind of two different implementations on that end.
I got one more question before we go into the build your own modular rollup exercise. And this is a question I got from a programmer friend of mine a couple of days ago at a bar. And he was asking me like first principles of blockchain. He's a very smart guy, but I think he was actually testing like why blockchain even exists. And you mentioned database. And like from a programmer's perspective, like first off, like how is a blockchain? Because, okay, how is a blockchain different from these databases? Like you mentioned that databases are baked into some of these chains. Like how is a chain different from a database? And then why is that like that on-chain component important and necessary?
Yeah, so databases store more local memory, so they store like read and write calls for specific transaction. The actual like transaction history is to the call data, which is stored directly to like Celestia or like Ethereum mainnet. So the kind of differentiator is like you can use an Excel spreadsheet instead of Celestia for like DA, but it's very expensive to make read and write requests. It's very slow. It's inefficient. It's not designed for financial applications. Blockchains, from a financial point of view, is the best distributed ledger in that you can send money, send transactions at the speed of light, essentially, in certain networks, and do so in a manner that's open source. You can trace the history of it. There's no like bottleneck in terms of how many transactions you can do. Like in theory, Ethereum can go on for decades, and it's not like a centralized server like Google is running or Amazon's running. And I think like the database is a very small part of it. So you not only do you have like a database, but you also have Ethereum has like thousands of validators, like Solana has thousands of validators. You have a better DA layer that can handle like sampling in a way that Excel spreadsheet couldn't. So long story answer here is the database is like a short-term solution, while blockchain is the best way to do payments or store data on chain as quickly as possible.
Cool. Some technical understandings there, which is always good. Coming back to Rob's first, maybe second question, which is this idea of being friends with all these different potential partners for movement. So before we start building a modular rollup, what I'd like to do is just understand a couple things. So I guess first, can the Move VM be integrated with every RAS provider currently?
Yep, we can be integrated to pretty much every RAS provider. We designed the VM to be completely modular. We first bring it to Avalanche, which was M1, which I'll get more into the roadmap later, and then brought it to the Ethereum rollup. So we designed it so it can be picked up and brought by any RAS, by any dealer. We have partnerships with all the biggest dealers, and we're announcing some pretty good rollup stack providers as well.
So it doesn't matter if it's like CK rollup, optimistic, if it's whatever it is, at the VM layer, movement can be there.
Yep. You just have to like kind of build like support for it. So you have to build like clients, or you need to build out like the RPCs. But it's not a too difficult process.
And same with DA, of course. And then what about settlement layer? Could we have Move rollups settled to Solana or to Avalanche or to Near or
to Bitcoin?
Yep, I've actually seen a Move Bitcoin implementation recently. So yeah, any settlement layer works. I would actually be interested to see actually Move rollup on Bitcoin, because that could be good from a security point of view, but haven't seen much work been done there. But yeah, any settlement layer works.
Okay, cool. So let's assume that I'm a game developer and I'm set on using the Move VM.
Yep.
Neutrally, right? Assuming you have no private interests in anything other than just building the best environment to build a game. How are you building a modular rollup for a game using Move VM? What settlement layer using what TA? What type of rollup? How are you going to build this game-based rollup?
Well,
VM?
I think the first thing that's more important is that you build a good game first. Like build up a community, like build up the actual game before you worry about what blockchain it's on. So that's where I'd start. And then once you have that game and the ecosystem, and now you're ready to use blockchain, and you want to use Move, which we would encourage for gaming, you probably want to use Ethereum for settlements, just the best storage of value at the moment, and you can have liquidity for your NFT marketplaces and actually have users on chain. On the DA side, it's kind of where it gets more interesting, because Celestia is obviously the only one that's live right now. You also have Near DA, which in theory is cheaper, and then you'll have like IGN DA coming out. I think IGN DA is particularly interesting because in theory it can handle 1 gigabyte per second, which is more designed for high throughput virtual machines. So we're doing a lot of benchmarking internally on comparing Celestia versus IGN DA implementation versus an Avail implementation. And it seems like if IGN DA can hit the benchmarks, it's proposing to be a great candidate for gaming applications. And you also get the security from native ETH, and it's not a different consensus mechanism. On the rollup stack side, I think a ZK rollup would be the best, because you want instant withdrawal times. You don't want to wait long time. So that kind of like narrows it down to like the Polygon CDK, Sovereign SDK, and I'm sure like a few other ZK stacks are coming up.
So a bet on the Move VM would theoretically be a bet on somebody to build a great game, for example, and thus to put it onto the Move VM, or build it with the Move VM under it as the VM layer, which would then accrue a ton of value to basically the idea of the technology behind the Move VM. Like from your perspective, you should be incentivizing and encouraging as many builders to build great shit on Move VM.
Yep. So gaming is one aspect. I think we're focused mainly on DeFi right now, because in order to have a successful chain, you need liquidity on chain, you need users that kind of degenerate out. So we built our core DeFi system, which we're announcing like every day basically, and gaming is a huge focus. I think one of the benefits that we have is that we have like two giants behind our shoulders that both have substantial amount of capital, and both ecosystems are pouring a lot of money into gaming, specifically in Southeast Asia, Korea. Sui is doing a great job, and Aptos is doing a great job of reaching Korea adoption. And fortunately, we get the benefit of like those fruits where we work pretty closely with like systems. It's generally pretty friendly, and we can kind of work together and move adoption.
Yeah, and I asked this one on the back of that one specifically for Move. It's interesting that Aptos and Sui are obviously involved at that level. It's quite a nice advantage. But with regards to value accrual in the modular stack, like how are you thinking about like obviously Celestia's price number go up, right? But like how are you thinking about like I send a transaction onto this modular rope that we just built up on this game. Like each part of the stack is somehow accruing some sort of value, which also then theoretically gets accrued back to the user because they're getting a better experience, better lower fees, better UX. But like what else? What are we missing? Like where does the value accrue for the modular stack? What's the business model for the modular stack infra pieces? Like how are we thinking about like comparatively valuing these things?
Yes. So like the business model for like traditional like Arbitrum optimism has always been sequencer level. So you charge sequencer fees for the EVM, and that's how you make money. It's a pretty decent business model, like they're printing money essentially. But the problem there is when you choose next gen VMs, and the thesis is low fees. So with the Solana VM, with the Move VM, you have low fees because you have parallelized runtimes, you have localized fee markets. So the fees are actually pretty much next to zero, which means the sequencer fees are pretty much nothing. So the value proposal actually goes away for next-gen VMs in the modular thesis. As DA becomes more cheaper, sequencer fees actually get progressively lower. So you can look at like Manta's fees. Their sequencer fees went down a lot in a good way because it's a better user experience for users. You're not paying $5 for transactions, but the business model slowly diminishes. What's kind of my thesis and how we're positioning is the value actually accrues to the token at a sequencer level. So for context, we have M1, which is kind of layer one built on the Sonoma consensus. That turns into a decentralized sequencer, or decentralized shared sequencer to power our Ethereum rollup. So what that means is if I'm a validator, I can now stake our native token to participate in sequencing and actually get a percentage of the fees. So yeah, even in this world where next-gen VMs dominate on Ethereum, which is the thesis behind movement, and the sequencer fees are pretty low, those fees get distributed to all the validators. And it's actually a value accrual mechanism back to the token because validators need to stake the native token to participate in sequencing. And you can make the decentralized sequencer permissionless eventually. So long story short is the decentralized sequencer is how I see the market trending over the next 2 years. As sequencer fees diminish, is actually economic incentive for Arbitrum optimism, these rollups, to transition to a decentralized sequencer because now you can require the native token to be staked to participate in sequencing.
So
Steven didn't want to tell us that, Rob.
No, he didn't. He said it was a research task or problem. We were grilling Steven on Arbitrum staking, and he said, we were asking him like when ARB staking, and my hypothesis at the time was that ARB staking, if it were to occur, it wouldn't occur at the protocol level. It would occur above the protocol level at maybe the application level. And that wouldn't be a concern of the Arbitrum DAO or off-chain labs. But what you're saying is that as sequencer fees are driven to zero, then Arbitrum staking actually would occur at the protocol level, and Arbitrum would transition into this proof of stake sequencer model, if you will.
Yeah, I think Arbitrum is Arbitrum optimism obviously are very successful. It would need to take a lot for them to move it, and I don't think it's on their roadmap. I think they have other priorities like EVM++, and they're doing a good job on that end. I think this more applies for next-gen VMs. Like we're talking about the Fuels of the world, the Moves of the world, SVMs of the world. They're bringing the next-gen runtime to Ethereum, or the fees are like zero, basically. So Arbitrum fees will always have fees because it's EVM, and the next 2 years they'll probably have fees, so they don't have much of incentive to use decentralized sequencers. While MoveVM, SVM, they have low fees. So it's more imperative that we use a decentralized sequencer staking model or have like a staking hub, so we actually have business for our company.
Okay, I got one more question on the Arbitrum framework specifically, because you were on a panel in New York, and I think I texted you after the panel, and I was like, "Hey, Arbitrum actually has this announcement with Espresso that they're going to use some shared sequencer at some time," and your response was basically like, "That's never going to happen." So, could you like just explain that a little bit more as far as like why Arbitrum would not make that transition to a shared sequencer?
You're gonna get me in trouble. But yeah, I think it's just like it's about economic incentives, right? Arbitrum's printing money, Base is printing money. Like, there's no economic incentive for them to use a decentralized sequencer in the short to midterm, which is the frame of reference. In a 20-year landscape, 30-year landscape, sure. Like, I buy centralized sequencers are flawed. Decentralized sequencers and shared sequencers will dominate the EVM market as well as next-gen VM markets. But the fact of the matter is today is that it's so profitable to run a centralized sequencer. In the near to short term or short to midterm, it doesn't make sense for Arbitrum Optimism or any EVM chain really to use a decentralized sequencer. It does make a lot of sense for next-gen VMs that are prioritizing low-fee markets to use shared sequencers because you have business models baked into it, because you have token staking, and it's also like you need a shared sequencer usually to handle the parallelization, the high throughput benefits. You can't rely on a single point of failure. So my thesis is that Arbitrum and Optimism, even if they advertise it, I think that was in reference to Arbitrum Orbit, or it's probably like some kind of roadmap things. We're probably not going to see that adopted in Arbitrum mainnet for a very, very long time. I hope the espresso community doesn't kill me after this.
That's our next podcast, so we'll make sure to get the roadmap from them too.
Literally. So back to the where we got going on this, which is really good, is that value accrual. So let's just get our facts straight. So is DA this rise of alt DA, is this causing a race to the bottom for sequencer fees? Is that kind of what's happening? Is this going to significantly reduce all sequencer fees?
Yeah, I mean, you're seeing it already on like Twitter, right? So like, you see like Near competing with Celestia on sequencer on like the DA fee. So right now, Near is exponentially cheaper than Celestia for DA, even though like Celestia can customize it and decrease if they wanted to, but they're not choosing to. So in this like 2-year, 3-year horizon where you have 4 live DA layers, they're all going to compete for these big roll-up brands to deploy on top of them. So they'll change their fee models to like attract more users. And then B, it's going to be like, okay, if Celestia decreases their fees, how does EigenDA respond? If EigenDA responds, how does Avail respond? So it's going to be this kind of like jockeying between different dealers. I'm sure there's like 5 of the dealers in the pipeline ready to launch, and I've heard of a few. So in this world where like DA is all decreasing their costs, now you're like, okay, what happens to sequencer fees? If a transaction, like let's say it was a $10 to a transaction at Ethereum mainnet, Celestia makes that $2 because of their great DA sampling, and then it's a progressively lower fee structure. Now the amount cost per transaction goes from $2 to $1.50 to $1. It probably hits a lower bound somewhere, which makes the sequencer fees, which are a percentage of that dollar, exponentially less important. So it's kind of a race to the bottom of the DA level as well as like the RAS level as well, which kind of renders the sequencer fees long-term a race to the bottom as well. And also centralized sequencers aren't the best, as we've seen, with downtime issues and whatnot.
Okay, and then so with the alternative VM thesis, how is this similar to the DA situation, and how is this different? I understand the validating level with the token and the staking for sequencing aspect. So maybe if you tie that into the answer, how is the race to the bottom of DA costs similar or different, and how is that affecting the way you're thinking about like the business model?
Yeah, the whole thesis behind next-gen VMs, and if you go on like Solana or Aptos and Sui, the fees are literally like 0.0001. The thesis behind next-gen VMs is localized fee markets for like consistent fee structures, parallel execution, so there's no bottleneck in throughput. So you don't have crowded fee markets. A great example is like during high peaks of like on use of Arbitrum, GMX goes crazy, which drives Arbitrum gas fees goes crazy, and the sequencer prints. That doesn't happen in Move or SVM because if there's an app that goes crazy, it's the VM itself can handle the state bloat, so it doesn't pass it on to the fee markets. It just stays very cheap. So you always have consistent, like next to nothing fee, which means the sequencer itself is pretty unprofitable if it's a centralized sequencer. So I wouldn't say the VM space is at a race to the bottom. It's probably going to compete on like devs. It's going to compete on like security, on like speed. That's where the competition. There's not a race to the bottom because like Move, SVM, Fuel, they all are like pretty much next to nothing gas fees. The token incentive model for the sequencer is kind of how you actually have business model and value accrual back to the token, because traditional layer 2 tokens are just governance models, not really any staking or gas fees. So we'll see a lot more experimentation coming there. I think Starknet's doing something interesting where they have like Stark tokens, gas fees, and they have like some kind of share sequencing hub. I'm not too familiar with it, but heard a lot of great things.
Yeah, they got in trouble for not being Ethereum aligned, apparently, which was kind of an interesting one because they're very Ethereum aligned, I think, but they are like the furthest out in the CK rollup stack that allows them to have Cairo VM, which is actually a sleeper alt VM that nobody talks about for some reason. Because like maybe they're not like super involved in the modular conversation. But I think Starknet's going to do well. Well, thank you for answering that. I'd like to take some time to dive into the Move framework. What you guys are doing with Cosmos and IBC, some of the roadmap items. So maybe just take us away as you see fit, and we'll kind of jump in as we have questions.
Yeah, I think the thesis of what we want to build is always permissionless interoperability. Like I was building on Aptos, building on Sui, and like I wanted to try new bridges, I wanted to try new oracles, but I couldn't do that in like a monolithic environment. So with M2 and the Move stack, we kind of have enable anyone to like customize their own infrastructure. So for example, we built the first Move Hyperlane module. So anyone, let's say you're on Manta, you're on Eclipse, you connect to M2, which is an Ethereum rollup, or connect to any Move rollups pre-permissionlessly. You don't need like a third-party bridge to do integration for you. You can do it in under an hour probably. And the second thing is on IBC. I think Cosmos is something that has been slept on for a while. It's kind of app chain thesis, and the hub has kind of discontinued it. But now with Celestia has brought like a new vigor to the ecosystem. And with that, I believe IBC is one of the most powerful technologies in the space, connecting not only to the Cosmos hub, but as well as players like Noble, which bring USDC on chain. So we're announcing the first Move IBC module that connects the broader Move ecosystem to the Cosmos system. So we'll be powered by Union, who will be building out the IBC compatibility for a virtual machine, which allows us A, to be fully compatible with the Cosmos system, B, have Noble's USDC on chain on testnet and mainnet, and then C, be compatible with players like Stry, which are liquid staking, Kepler, Leap, and some of all like the fun Cosmos stuff that we grown to love.
Okay, so you guys have like the M1, M2. Maybe we can get to that kind of like separation in a moment. As we talk about the Move framework, I think we briefly touched on this earlier. We already kind of like unbundled the entire roll-up stack, and this leads us to modularity. So when it, once we accept like the promise of like alternative VMs and what they do to roll up throughput, why did you guys choose the Move language specifically? Like what is it about Move that separates and empowers greater throughput, more security than some of the other like options for VMs that you guys could have chosen?
I mean, it goes back to Facebook's days, right? Facebook was going to build a stablecoin to power their billion users on Facebook, and they looked at the EVM and was like, okay, if I have a billion users with like tens of billions of dollars and it's living on this EVM, it's going to get hacked inevitably. So they took a step back, built a complete VM and language from scratch. It was Rust-based language. So Move is built like with all the security in mind to handle a Facebook-style app on chain. So think of it like the Solana virtual machine and your favorite auditor combined into one VM. So the concept of formal verification is baked into the virtual machine. So you have built-in bytecode verifier and compiler. So traditionally, in smart contracts, when you execute a smart contract, there's no one saying like stopping it if it's a flawed line. So for example, reinstance attacks are a huge thing. The Kyber attack was like attack vector where 0.00001% probability of being picked up, which means it's just human error and fundamentally impossible for anyone to like pick up on it. That would have been completely stopped by Move because the Move runtime would have flagged it as like, hey, there's a reinstance bug here. we don't allow re-entity in a virtual machine, flag it, compile time, and don't execute it. So it kind of audits the code in real time because you have formal verification built into the VM. And the EVM and other virtual machines, you have to go to auditor each time you want to update your code, which can work the first time, it can work the second time, but the 73rd time, when you have a 73rd update, maybe there's a line that you missed, which just cost you $10 million and just lost your entire user base. I think Stars Arena is a great example. It was a SocialFi app on Avalanche. It was a good team, just wanted to push their product to mainnet, and they got extreme traction in 3 days, and then a registry bug crippled them, and now they're nothing, right? And they're trying to work on it again. But the point is the velocity of production in crypto is very slow, in that if I have a killer idea, if I want to build the next Facebook in my dorm, it takes me a really long time. I need to build the code out, spend months auditing it, pay $100K to my favorite auditor, and even then there's a good chance to get me hacked. I think the number is like 90% of every EVM protocol is at risk of being attacked right now. Like Lido is pretty much the edge case, but even that's like unsure. So Move is designed to increase the velocity of production. You can deploy code to mainnet. 95% of all bugs are pretty much handled. And we haven't, knock on wood, seen an attack yet. We'll see how the thesis plays out over the next few years, but Move was built with security in mind.
Yep, totally makes sense. There's several projects out there building alternative VMs. Makes total sense why you guys are embedding formal verification into the alternative VM logic. That'll hopefully increase the velocity of development and speed up like how quickly these projects can go to market and deploy on mainnet, which kind of brings me back to a thought I had a little bit earlier in this conversation, which was that by enabling like essentially modularity, by enabling modularity and also kind of like bringing all these things together, you're able to open up like this design space for developers that maybe aren't blockchain native. So all they have to do, like, because all of the on-chain work is becoming much, much easier, it means that a lot of the work is now going off-chain. And that's where the innovation is going to happen. And that means that blockchain, like non-natives are able to come in and develop, because now a lot of that creative work is happening off-chain. And that's because on-chain work is becoming much, much easier.
Yeah, I think you have like much more customizations. Like if I want to build like a game like you touched on and I want a parallelized runtime, in the past I couldn't just like fork Solana, right? But now I can go to my favorite RAS, do one click rollup, and now I have a move rollup for my own use case, which wasn't possible a year ago. So you have much more experimentation in the space. I do think modularity introduces more like complexities, but it's going to be like unraveling of technology and then a kind of coupling once like the winners are chosen.
Yeah, that's what we see almost every cycle, is like everything kind of like unravels. And then there's the bundlers and the unbundlers, depending on whether or not you want customization or you want convenience. And these are trends that we see in like several industries, almost every cycle, as things kind of dilate and compress, and we see those trends.
And Rob, you bring up a really good point about the onboarding of developers. I think that's one of the biggest, unique aspects of movement and alternative VMs. Rushi, I'd love to hear more about how that's going for you guys, and then we can dive back into like the M1 and M2 and kind of what our kind of community and users can expect. But let's touch on how alternative VMs are onboarding devs. Move, Fluent, other VMs. Kind of what's the overall thought process there? Why is it easier? What's your thoughts on onboarding new devs? How are you doing it?
I think our thesis is more aligned with like Eclipse's and Solana thesis, where we have like these two huge monolithic environments behind us, like Aptos and Suite combined, like $15 billion network. It's like number 6 developer count. Move is growing exponentially in Korea, Southeast Asia, Taiwan. And the bet is, okay, over the next 3 to 4 years, we're going to see a lot of Move development because of the firepower of these two chains. A lot of users are going to want to live on Ethereum still, live on Celestia, be part of the modular thesis, be obviously compatible, all these different benefits that you couldn't get on monolithic chains. So that's how we kind of work with Aptos and Sui, in that we're extending the umbrella of Move to environments that were typically untouched. And same with Eclipse, extending the umbrella of SVM to Ethereum and whatnot. Fluent is like an interesting play because they're bringing in new developers to the space. They're bringing JavaScript developers, TypeScript developers, and doing a good job of kind of increasing the programming language horizon. We're focused more on like A, inheriting the work that two big giants have done, and then B, kind of focusing on increasing security mindshare within the Ethereum ecosystem. So converting Rust developers to Move developers, as well as Move is a pretty easy language to pick up. It's like, I like to say like Move is to Rust as React is to JavaScript. So it's much more intuitive, it's designed in a specific use case. So we do a lot of university hackathons and have been seeing a lot of good trajectory there.
Nice. Yeah, developing developer experience is huge. Developer relationships is huge, and love to see you guys going the university route. That's where like a lot of crypto curious people are, and it seems like that's where the altVM thesis fits. Is to onboard these like crypto curious people that aren't necessarily natives.
Yep.
So I want to push into this M1 M2 conversation. Kind of like unpack these things for us, unbundle them. What is M1? What is M2? And why did you decide to kind of like separate these two pieces of the stack?
Yeah, so this comes into like November of last year when we first started thinking about modularity. At the time, like this is post FEX and everyone was like down bad. Like every developer in the space kind of left pretty much, especially in the moving system. At the time, there's only two systems where you could build a Rust-based VM. It was like Polkadot, Cosmos, and Avalanche. And then we reached out to Avalanche. It was a great time, and we kind of like really realized this is where we wanted to bootstrap liquidity, create decentralized validator set, and then kind of got in the modular space where it made sense to like launch Move ETH2. And then as we kind of established roadmap, we realized like all the sequencer stuff I discussed, right? In this world, we have next-gen VMs coming to Ethereum. It's very difficult to have centralized sequencers because the fees are going to be next to nothing. Centralized sequencers have large downtimes. So if we're doing 10,000 transactions per second, which is different than the EVM use cases, the sequencer won't be able to handle that because it's a one node essentially sequencing all these transactions. So we need a decentralized sequencer that could scale. And specifically, we need a sequencer that had low hardware requirements, instant finality, so handle the essential throughput that we're having, and C, have native alternative token staking. So that pretty much brings us down to like Tendermint and Snowman consensus. And Snowman consensus was the right place to do. So M1 is a subnet on the Avalanche consensus. We don't say the word subnet, so we call it L1. And M2 is the Ethereum rollup that uses the Move machine. M1 then transitions into M2 by being a decentralized sequencer. So every transaction that occurs in M2 mainnet is sequenced by the validator as part of M1. So it's a decentralized shared sequencer powering the Ethereum rollup. So it's kind of a one mega Frankenstein experiment. And if it works, it's going to be like probably the most decentralized and highest uptime next-gen rollup on Ethereum. Kind of visual is like you have the Move VM for execution that's even compatible. You have Ethereum for settlement. You have M1 for sequencing, and then you have Celestia for DA.
Then anybody can build a top. So M1 is like sequencing. So it's not like the settlement layer. You can't build a movement rollup with M1 as a settlement layer, can you?
So you can launch your own Move rollup with the Move stack, which means you can connect to whatever rollup framework, you can use UK stack, OP stack, whatever, use whatever DA layer, and you connect to M1 as a shared sequencer. So let's say you have M2, which is the main chain, and you want to launch your own gaming rollup. You can launch your own gaming rollup with the Move stack, use the Move VM, use whatever other parts you want, use whatever RAS, connect to the decentralized sequencer, so you have composability like we touched on. So if you're doing a swap between M2 and you have your own order book chain, it's atomic composability between different rollups. It's actually more atomically composable because it's a parallelized chain, and you're not waiting for a state to finish on each different chains. But yes, if you're launching your Move rollup, you can connect for sequencing purposes, but it wouldn't be for settlement purposes. You'd probably still settle on Ethereum.
Yeah, makes sense. And then interop is the other part of the modular stack that is under discussed, but will soon be discussed more as people are getting more involved. You mentioned something to do with the Chads over at Union for IBC and Move interop. Could you take us a little bit deeper as to what that looks like, as well as some of the other interesting items on the roadmap, which you've subtly hinted at today, right before our lovely podcast?
Yeah, on the IBC side, the moving system has never been IBC compatible, really. So we're really looking to bring the Aptos and Sui dApps, bring them to the atmosphere. So let's say, for example, your DEX and Aptos, now you can use Osmosis assets. You can have stake TIA into your DEX, which gives you a lot more volume and a lot more users. Building the first DEX and Aptos was pretty painful in that there was like 2 assets on chain, which was APT and like one other token that had next to no users. This was after FTX, of course. And then as that scaled, we're like, okay, the bottleneck for new chains and Monolithic environments is very difficult to bootstrap liquidity and bootstrap assets that users want. So with modular chains and IBC enablement, now if you're launching a Move DEX, you can have your Move assets and whatever you want in that ecosystem, but now you can have IBC assets natively. You can have USDC via Noble natively. You can have on and off ramps from Kata natively. And then we're like, you have native ETH because you live on Ethereum. So that's kind of the thesis, like having permissions and interoperability. You can customize your oracles with the Move stack. You can customize whatever bridging solutions you want, customize whatever rollup stack. And then as for the roadmap where we're at today, we have DevNet fully live. You can check out docs.movement labs XYZ. We have incentivized testnet coming up next month, and then mainnet shortly after that. And then we'll be rewarding community members, if you know what I mean.
Yes, we do know what you mean, Rushi. Rewarding community members, indeed. Very hint.
With memes, of course.
With memes.
With memes.
Community members. I own a Pudgy Penguin. That makes me a community member. I like being a Pudgy Penguin. We get a lot of community members, if you guys haven't realized.
No comment.
We get around. Well, Rushi, thank you so much for coming on and having a good vibe, putting up with this Panamanian Wi-Fi. I think the recording will be quite nice. Covered up a lot here, and it's just exciting, man. I think Rob's comment at the very beginning just set the tone, and I think it just continues to set the tone of the modular vision, the modular idea, where it's just like not everybody can be friends, but it's all just this composability and this kind of like interactive nature of just building things together and opening your mind to what's possible and reducing this maximalistic monolithic mindset. And I'm super happy to continue to see how Move plays the part in that, and look forward to the launch.
Yeah, appreciate it, man. Thanks, guys, for having me on. And if you're at ETH Denver, Movement will be around. The roll-up will be around. Feel free to say hi.
Yes, sir. Yes, sir. Thanks for coming on, Rushi. This was a blast.
Thanks, guys. Appreciate the time.